everyone, my name is Florian and I work at Facebook. Today I want to share with you a story that started in 2008. Whoops, seems it's not working. Yes, better. So this story, I've always been fond of making video games because I think that playing to video game is fun, but creating is even more exciting. So that's why I created gdevelop. It's an open source software that anyone can use to create video games. And things are not going wrong. Sorry. So gdevelop, you can create video games, and in fact, anyone can create video games because it's designed to be used by anyone. Why? Because it's based on visual editors, so that you can create the levels of your games, and also on visual programming, so that anyone can create the rules of the game and the logic. I will show an example just after. So the software is outputting HTML5 games. And this is how it looked. I say it looked because it's the whole version that was all done in C++. So the idea is that you have the level of your game, the objects on the right, and we'll see the events that make the rules of the game. So what I'm going to show you is this button that there is on the level. I want that when the player is stepping on it, I want it to be pressed, and I want the platform to go up in the air so that the player can continue in the level. So let's see how to do it. So I have the button that I placed on my level, and I had an event composed of a condition. A condition is like a if in a if-then, and I will add a condition so that where there is a collision between the player and the trigger, I will launch two actions. The first one will be to change the animation of the trigger so that the animation is the number 1, which is the state where the trigger is pressed. I will then add another action to move the platform up in the air. So I will add a force to the platform and set it to a value so that it goes in the air. I can then press play and have a preview of my level. So yeah, that's working. And so that's the whole idea of the software, and that enables people to create quite advanced games. Here are a few examples of games that were created using gdevelop. By the way, I made the one with the cat. Check it out, it's quite fun. So yeah, things were going quite well. And now, fast forward to 2 years ago, so in 2016. Things were all right, but the editor was getting really old. It was having a lot of cross-platform issues with the UI toolkit, and the support of macOS and Linux was honestly quite bad. And iterating on the software was quite slow, C++, and building the UI was slow and limited to all the UI components and things. Honestly, the UX would need some enhancement. And the entry barrier for new contributors was also quite high, C++. So it was time to react. What do we want? We want a new software, a new editor, sorry, that is cross-platform and that has all the things that I described before. But we don't want to rewrite the whole thing. Why? Because we want to keep the full compatibility with the projects that are already existing. Users won't be happy if they have to remake everything using the new version. And also, nobody got time to wait for a rewrite. There are games to be made. So my question at this moment was, could web technology help? I've been doing a lot of React and React Native, and I was really fond of the whole way of doing UI with it. So I was like, let's try to use it. How could we do? Let's take a look at the C++ code base that we had. There are all the core classes to describe what a game is, what is a scene, objects, what are the events, and how they are translated to JavaScript. And that is doing the game exporter, meaning that it's taking your whole game and outputting it as an HTML5 game in JavaScript. And there was also all the graphical interface and the file system. So the idea was, can we reuse the top part and rewrite the interface? For example, we could use, obviously, React to make the interface and use a set of browser or Node.js API to interact with the file system, so that we could run this software either on a browser or on Node.js or on Electron to package our application in Electron, which is a kind of Chrome with a Node API. So that's for the UI, but we still want to reuse our core classes as a JavaScript library. And for this, we're gonna use Emscripten. Before this, let's have a quick overview at WebAssembly. So WebAssembly, it's a low-level language that is available now in your browsers. And the idea is that as it's a low-level language, it's easy for browser to optimize it so that it's running at speed that is nearly a native speed. And that's not a language that you would write by hand, contrary to JavaScript, because it's kind of an assembly language. But you are compiling to this language, and that's exactly what Emscripten is doing. The idea of this project, which was started at Mozilla, if I'm not mistaken, is that you take your C++ code base that you already have, and you run it through Clang, which is a C++ compiler. And Clang is outputting the LLVM intermediate representation. And then instead of using this representation and translate it to real assembly to have a binary running on your system, you run it through Emscripten, which outputs WebAssembly. And you get something that is running on the web. So let's see how to use it. If you want to try it, it's pretty simple. You git clone the SDK, you install and activate the latest SDK, and then you can call it as a C compiler or a C++ compiler on your source in C or C++, and you get the output that you can run in Node. For larger projects like gdevelop, you can actually swap the compiler by the compiler provided by Emscripten. So the idea is that it's almost something that you don't see as a native developer. It's just that you get an output as WebAssembly. Once you get this WebAssembly compiled version of your code base, the idea is, how can we reuse this in our JavaScript? So the first thing to do is to expose the existing classes that you have. So beware, that's some C++. The idea is that here these are two classes that we're gonna expose to WebAssembly. The first one is an object container. So the idea is that you have objects in your game. So I have a list of objects, and this class is providing a few methods that you can use to insert or get an object. And the second one is actually a layout. So that's a scene that you see on the game containing the objects and linking the events and the objects. And here you can, for example, set the name and get the name of the scene. And it's inheriting the objects container, so the scene, the layout, will be able to also have a list of objects. So that's the C++ code that I had. And to expose it to WebAssembly, we have to create bindings. So I use this language called WebIDL, which is a way to describe the interface of your classes so that you can use this WebIDL binder, which is provided by Emscripten. And this will create all the glue code that you put between the JavaScript and the WebAssembly module. The result is that once you run the binder and WebAssembly, and Emscripten, you get a nice interface that you can reuse. First, you have to instantiate the module that was created from Emscripten, and then you can create objects like usual JavaScript objects, set the name, so I'm calling a method and then getting back the result. So that's pretty easy to use. The only thing is that it's not real JavaScript objects. If you look in your browser what's the content of this object, you will see that it's nothing but a pointer, like a number, that points to some area in the memory of WebAssembly. So that's the thing. It's real JavaScript object, but you can't see the content because they are in this WebAssembly memory. A few things to know. Primitive types are converted automatically, so float, booleans, including the strings in JavaScript, so that's really convenient. And object references can be converted either to pointers in C++ or to references if you use them. So that's also really convenient. And finally, all the input and output stream that you're using in C++ or in C are sent to the console. So here again, it's really convenient. And if you run this in your browser, you can actually see that on the top, there are some output that is written by the module, so it's working. And then I can create a layout, set the name, get the name, it's working. So when you have your code base that you made for a lot of years, and it's now running in the browser, you're like, whoa, it's working. That was my face when I first saw it. Star Wars Episode 1, sorry. A few things to know. First thing, memory management requires care, because as all the objects that you are defining in JavaScript are created in the WebAssembly world, you have to destroy them. So be careful, and for example, in React, when you create it in your component in mount, you have also to destroy it in the component within mount. Or you can use hooks. Something to also keep in mind is that output files can be quite large. For example, for gdevelop, it's 3 megabytes when everything is compiled. And it's a lot, but honestly, I don't care. I don't care because I'm making a desktop application, so 3 megabytes, more or less, that's the same thing. Next thing to know is that it's really, really important to have a full test set of your library so that you can get confident in the fact that it's working, because that's the kind of error that you can get when something is going wrong in your WebAssembly module. It's not helpful at all. And it can happen for quite a few things: a wrong type of parameter, some parameter that you forgot, or you've used an object that you deleted before. The whole thing will explode in the WebAssembly world. So let's be careful and have a good test set. Now that we have this, we have been successfully moving our code base, our internal code base, from C++ to the JavaScript world, well, the browser world. So now the idea is, can we rewrite the interface that we had, but in React? So let's see how to do it. And the first thing to do is to find a good component library, because the thing is that the interface that I had was quite complex, and I don't want to rewrite everything from scratch. By everything, I mean all of these things. So context menu, checkboxes, inputs, color pickers, toolbars, all these usual things that you have in native application, you have to mostly recreate them on the web. So that's why I searched for components libraries, and I found Material UI, React Toolbox, Blueprint. There are a bunch of others. If you have to choose one for your next application, what I did is I looked at a few key features. First thing was the list of components. Is it exhaustive enough for gdevelop? And I end up with Material UI for it. Then, has the library a good theming support? The idea is that it's also a good idea to be able to, at some point, change the interface, especially for game editor, where people like to spend a lot of time in it and like to have a dark theme, for example. Then, has it a support for nested dialogues? So the idea is that here, again, the software is quite complex. So we have to open window inside window sometimes. So let's take a look at the flexibility of the component. Are you able to override a few things from time to time? What about the quality of the documentation? Also important. And finally, is it blazing fast? Once you have this, let's take a look at other patterns that we want to recreate in our new software. So the idea is that we have lots of large lists that are displaying a lot of objects. And we will want to have also drag and drop of this list. So let's see how to do it. The solution here was to use a virtualized list, because I want to display list of dozens to hundreds of elements. And it was too much, especially because I was making calls to WebAssembly for each element. So I've used React Virtualize and React Sortable HOC. To give you a simple example, here is a list of objects, so it's just iterating on objects and displaying a row for every object. If you want to move it to a virtualized list, you use a list that is provided by React Virtualize, and instead of mapping on your objects, you just you give this row renderer, which is called every time a row has to be displayed on the screen, because only the rows that are on the screen will be rendered. And to get this drag and drop support, you can wrap your object row into this sortable element HOC, and the same thing for the container of the list. So in a few lines of code, you can actually get a list that is virtualized and where drag and drop is supported. So that's pretty awesome. Next thing that we want is to have games editors that we can move on the screen. Because again, it's a game editor, so people are spending a lot of time inside and want to be able to customize their workspace. So for this, I've looked at the different window manager libraries that are available, and I have found this one, React Mosaic, which is really awesome because it makes everything for you, so you are able to create window and to drag and drop them on the screen. So pretty awesome, and it's using React DND under the hood. Next thing is the keyboard handling. In a software like gdevelop, you have to handle shortcuts because people will ask you for these shortcuts if they are not present. And also, you have to get a good browsing of your elements using keyboard. So for focusing elements, well, things are quite simple. Just don't forget when you're opening a new window to add the focus on some elements so that the user can immediately start using his keyboard. And so yeah, in your component environment, just put the focus on your component or use a hook. Then for the keyboard, I've done my own solution by just having a class that handles, that listen to the keyboard, the key pressed, and then call methods. But I've found this approach done by blueprint.js, and it's quite beautiful with this hotkey component that you can add in your render methods, and that's a good way of making these hotkeys, and it's also a good idea to have it as a React component because you can inspect the render methods of your component and see as it support for hotkeys or not. Okay, next thing, we want to display large trees of information. In my case, it was these events that allow you to create that allow you to program in a way your game. So what I've done here is to use virtualization again, and this time using React sortable tree, which is doing also a really good job at making this complex nodes, tree of nodes, sorry. And the thing is that under the hood, it's a virtualized list built on React Virtualize, so that every node that you see here on the screen is actually a row of a list that is virtualized. So performance is good, and I've tweaked this quite a lot so that it looks like this. For the most complex thing that I reached was to make this rendering of the levels, and we want to display levels that can be quite large with lots of objects. So at this moment, the DOM is not maybe powerful enough to do it. So you can, at this moment, use WebGL. Well, not directly, because it's a lot of work to use WebGL, but a library like Phaser, 3.js, or Pixie.js. I've used Pixie.js because it's the rendering library that I'm using for the game. So I might as well use it for the editor. Sometimes still, the DOM is powerful enough for making things that are a bit simpler. For example, this is a preview of the polygon that describes the collision mask of your object that will be used, for example, to detect a collision during the game. So here I've used SVG and all the components that are provided to display this polygon, and you can even drag and drop the vertices of the polygon by implementing this on mouse down, up, or over. so that you get something that is quite complete, and as it's done using React, it's quite easy to read and to understand, compared to something that you have to do manually using WebGL. Sometimes things aren't native enough, so that, for example, when you want to display a context menu, you can use the context menu of Material UI, for example, but it does not feel native, and people will complain. It's too webbish. So here, what I've done is just to wrap the Electron APIs that are providing context menu, and as I still want my software to be able to run in a browser, what I've done is I've done 2 different implementations of the context menu, one using Material UI, and one using the Electron APIs. So I won't go through the code, but the idea is that you either render Material UI components or call the Electron APIs. Sometimes things are not fast enough, and the first thing that can happen is that your components are too slow to render, so it feels a bit webbish again. So here, what I've done is first to use why did you update, which was quite useful to see what components were rendering where they were not supposed to do. But now we have a profiler in React, and using this profiler, it's really easy to see using the cloud area that something is being rendered while it's not supposed to. For example, here you can see on the left that the project manager was re-rendered while it was hidden on the screen. And most of the time, using full component update is the answer to avoid re-rendering. Be careful, don't forget to measure the performance in production, because in development it's quite slower, and you can end up optimizing something that is in fact already fast in production. The second thing is that sometimes things are not fast enough because of the calls to the WebAssembly world. And in this case, it's because there are still an overhead for calling the JavaScript, the WebAssembly methods. And it can happen in particular if you're iterating on lots of objects and making call every time to WebAssembly. And if these calls are returning strings, they need to be converted. That's a lot of things. Most of the time, you won't notice it in the UI, but still, it can be useful if you're rendering long lists or trees to store the values inside the JavaScript world so that you don't have to cross the bridge to the WebAssembly world. Let's take a look at how the software now looks. Well, how it looked like when I got a first version working. And that's what it looks like now. So I'm creating a new sprite, which is a button, and I had the second animation, which is the button but pressed, and I had this animation name, and now I will put it on the level, and same thing as before, I will add the events so that when I step on the button, it is pressed and the platform goes up in the air. So you can see everything that I spoke before being used. So all the interface is done using Material UI, and here I'm adding the collision condition, and now the 2 actions. The first one, this time to move the platform up in the air. So same thing as before again. And the second action will be to change the animation of the button. When I'm done, I will click on Preview, generate the JavaScript for the game. And it's running. And same thing as before, because it's the same code base, so of course it's working. And you can notice that there is no issue of speed. The preview took the same time, and all the rest is speedy enough. The good advantage of this is that now I have ultra-fast iteration and testing on my software. Before, I had to wait for the recompilation of a few files every time I'm making a change. Now, it's a few seconds before Create React App is telling me, oh, it's compiled, and you can check the result. Even better, you can use Storybook or React Style Guidist to develop your components in isolation. And the thing is that I don't do unit test. Sorry. But actually, I do unit tests for things where there are logic, like the library. But for UI components, what I do is that I try to put every single one of them into a storybook story so that it's my visual testing. And it's, I think, really useful both for development speed and to ensure that when you upgrade to a new version of a library or when you refactor some component, things are still working without having to go through the full application. I also got auto-update and packaging done kind of automatically for me using Electron Builder so that I have an application that got updates from day one without me having to do anything. That was a huge pain when I was doing the native application to make all the installers, code signing, and even the result wasn't even good. So that's a huge thing that you can get for free, kind of, using Electron. And lots of other things. I got more contributors than before, because JavaScript. The startup time is kind of similar, a few seconds. People can try the software from their browser in seconds without downloading anything. So that's a huge selling point, meaning that anyone can go on the website of the software, see that, oh, this looks interesting. There is a try it online button. I click on it. I have the software running in my browser in 2 seconds or 3. So that's a huge selling point. Same thing in the documentation. I can now have links opening the examples, and people can just try what they're reading inside their browser. We could even port later the software to Android or iOS if on tablets or even phones, so that should work. And in fact, it's already working. So that's also a huge selling point if you want later to have a full cloud version. The integration with Dropbox, Google Drive, and all these services could also be something that we add later. So that's a lot of things that that were unlocked by moving to the web. There is a plot twist to my story. I'm not using WebAssembly. It's still all JavaScript. So the thing is that Emscripten was something called asm.js, which is a Fox and all the browsers supporting it. And the thing is that I've not updated to the latest version of Emscripten that is outputting WebAssembly because I'm too. But if at some point I want to switch to WebAssembly, I will get things that are going even faster. So when opening a large game or launching the preview for a large game, instead of waiting for 5 or 6 seconds, I will wait for maybe less. So great things are coming. Last thing that I want to tell you is what are our users saying, because that's what is important. And I'll be honest, the first version weren't so greatly appreciated by the users, but not because it was built on Electron or React or WebAssembly, just because it was lacking features that were already in the native version, because I can't rebuild everything at once, so I started with a small product with only a subset of the features. Even if the library, the core library, was having all the features, I still had to rewrite all the interface using React. And after 1 year of progressively adding back things, and faster than before, thanks to React and Storybook and all this development environment, people are saying that, wow, it's actually a great change, and compared to the previous version, it's even better. I even had someone who told me that he has to admit it. He can be now more productive using the latest version, gdevelop 5, rather than gdevelop 4. So that's great. I want to end up by giving back my Twitter handle. Follow me if you want to know more about WebAssembly, React.js, and video games. There is the link to the software if you want to try it or download it. And finally, the GitHub link for you that could be interested in it. And I want to say that now with React, we can build a website, mobile application using React Native, but also we can now create desktop applications that are ambitious and better than what we used to do in the native world. Thank you.